This is section 3.05 of the Unit 3 notes, owning a car. Today I am, as in you're the student, discussing costs involved in buying a car so that I can calculate the amount of car payments and auto insurance and predict the future value of a car. I will know I have it when I can solve problems involving buying and maintaining a car. The specific techniques we're looking at for today's lesson is 3D. Use technology to create amortization models to investigate automobile financing and compare buying a vehicle to leasing a vehicle. Owning a car, how much does it really cost? So here are some examples of deals that you see when going out to buy a car. These are coming from different types of advertisements from newspapers, online, whatever. You have things like save 25% from MSRP. You have a lease for $148 per month. You have 0% down for 60 months, etc., etc., etc. You have different types of models, different years and makes, etc. So how much are you actually paying for all this stuff? So these deals are nice. They get you interested in buying a car. However, what they don't tell you is how much interest you're actually using or you're actually accruing as you're going for these deals per month to buy these cars. Because you look at these deals and you think, well, how are they going to make their money if all these prices are so low? Well, there's some hidden things that are in there. Interest being one of those. They also offer other packages, other deals into these car payments that aren't advertised in here that they will get to you whenever you start actually going through the process of buying things. So we're going to look into purchasing a car, how to calculate the total payments, the monthly payments for purchasing a car, and we're also going to go a little bit through about the just very basic look at insurance, how to choosing your own different premiums for each type of insurance, and so on and so forth. So anyways, let's go to the next slide. I do have a video that I want us to watch. It's about buying a car or a used car. So I'm going to show you all this video. After we watch this video, I'm going to ask y'all if y'all are following in ClassKick, following through the notes in ClassKick. I'm going to ask you to type in what you think about the video. Did you learn anything about the video? Was there anything there that you already knew but you've got further clarification on and were more enlightened about the topic? Or were there questions about things that you that weren't answered from this video that you may want answered? Go ahead and type that in the box just to share your thoughts and just to write down what it is you felt about the video. Okay, so let's go ahead and watch this.
Yeesh, I really need a car.
Hi! Hello there! Hold on a minute. Have I got the perfect vehicle for you?
Is that a question?
No question about it. Here's your dream car. It's compact, high-tech, only driven by Grandma on Sundays.
No offense or anything, but I think I'm better off buying something brand new.
On the contrary, did you know that a new vehicle can lose almost half its value in the first few years?
What? Seriously?
That brand new car you're thinking of buying starts losing value the moment you drive it off the lot and loses the most value in the first few years. That's why buying a car that's a few years old can be a great way to save some cash. It's all right here in my trusty black book.
But I don't know where that car's been. Ugh.
Hey, watch it, lady. I've been around the block a few times, sure, but I'm still in tip-top shape.
What? A talking car? Well, I'm sold.
Great! It's a deal. I'll go get the paperwork.
You know, we're really just not right for each other.
I always wanted a talking car. We can say hi to joggers and sing songs on road trips together.
Whatever. What do you know about buying a used car anyway?
Just pick the newest, cheapest one. Simple.
That might just backfire on you.
I'm certainly not the cheapest. I don't think she gets it.
First of all, you've got to do your research. Start off by setting a realistic price range. You don't want to get stuck making monthly payments you can't afford down the road.
I see what you did there.
Only look for makes and models that fit into your price range. Keep in mind the cost of insurance and repairs, as well as the features you actually need.
Like mega awesome talking ability?
Like the junk you're hauling around. There's no way I can carry all that.
Yeah, I guess not. Maybe a roof rack, though?
Roof racks are so not my style.
You may be better off with a nice hatchback. Have a look over there.
Well, this one is pretty awful, but I like the sporty one. I'll buy this one instead. I can always throw on some talk radio.
Whoa, whoa, whoa. Pump the brakes there, Turbo.
Before you commit to a used car purchase, you should always evaluate the car. First, take a good long test drive to get a feel for the car and to spot any immediate problems. Then get the vehicle checked by a trusted independent mechanic. Finally, get a report of the vehicle's history based on the VIN.
The what now?
The vehicle identification number, or VIN, can usually be found on the driver's side where the windshield meets the dash. The VIN provides useful information on a car's accident and repair history, manufacturer recalls, and vehicle use.
Wait, hold the phone. It says here this hatchback has been used to deliver bowling balls to ski resorts for years, and it once got major water damage from rolling into a hot tub. No thanks.
Glad you checked, aren't you?
Heck yeah. I just wish I could afford a car as clever as you, but maybe with some more room.
We've got options for miles. Let's wheel and deal, huh?
Well, I'm no master negotiator.
You don't say.
Learning to effectively negotiate is very important, whether you're shopping at a dealership or buying direct from the previous owner.
And the most important part of negotiating is always being prepared to walk away.
I think I'm gonna take some time, do my research, and then come back with the perfect game plan.
Good idea. See you then. Remember, research, evaluate, negotiate.
Nice job, sales guy. You sure know how to close the deal.
Go take a joyride.
La 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 la.
I should have done my research.
So again, after watching that video, go ahead and put, if you're on Class Kick, one thing that you learned from the video in the box below. There's no right or wrong answer. Just simply want you to take the moment to compile what you learned, what you watched, and then put it into words in that box below. Okay, so let's go through some examples. Buying a car and making monthly payments. A lot of the steps that we're going to take are going to be very similar to paying for a house, going through the mortgage steps. So you'll be recognizing some of the steps that we use to purchase or to find these values. They're all based on amortization tables that have been made for you in these examples, and for the quizzes and for other problems as well. And we're going to use those tables to figure out certain things to add, subtract, or multiply to our problem. So, or subtract or divide, whatever. Anyways, example 1. I'm going to cover some of this and reveal it as we go. Tom is buying a new car for $14,350. He will finance $9,350 of it with a 4-year loan at 4% APR. What will his monthly payment be? So again, we're going to be using amortization tables to figure out how what his monthly payment will be. First thing we have to do in order to use the table, because if you look at the table, it's monthly payments per 1,000 borrowed. Again, there was an amortization formula that has compiled all of these numbers for different scenarios, different situations, and put them all into a table. We just need to use this table based on the information given to figure out what his monthly payment will be per 1,000 borrowed. So that means the first step is to figure out how many thousands we're borrowing for this car. So there's two numbers here. Tom is buying a new car for $14,350. However, he was only going to finance $9,350, which means he's basically making a $5,000 down payment and then financing the rest of it. So we're going to use this number right here to figure out how many thousands were borrowed. We're going to take the amount borrowed and divide it by 1,000. So $93.50 divided by 1,000 is 9.35. So he's borrowed about 9.35 thousands to purchase this car. Now we're going to calculate the monthly car payment, which is going to be the number of thousands borrowed times the payment per 1,000. So to figure out the payment per 1,000, we're going to use this table right here, which is based off of the APR, which is the first column, and then the amount of years we're taking out the loan, which is at the top row right here. So this is a 4-year loan, which is going to be this column right here, with a 4% APR, annual percentage rate. 4% APR is right here. And we're going to look at their intersection. And we see 22.579 per 1,000 borrowed is the monthly payment. So we're going to use that number with the amount of thousands borrowed, which is 9.35, and then multiply those two together. So again, 9.35 times 22.579, rounded to about 2 decimal places, because we are talking about money here. This is $211.11. So his monthly payment, based on all of this information here, will be $211.11 to purchase this car, to finance this car. That's it for example 1. You try number 1. David is buying a new car for $29,850. He will finance $27,850 of it with a 5-year loan at 3% APR. What will his monthly payment be? So again, similar to what we did in the previous problem, you need to calculate the number of thousands borrowed and then calculate the monthly car payment based on the amortization table given right here. So go ahead and pause this video. Do this on your own. If you're on ClassKick, go ahead and start answering each of these blanks and see if you can follow through the steps and answer them correctly. If you're on ClassKick, you can move this box to check your work to see if you're doing everything correctly. Otherwise, just make sure you're going through the work on your paper and pencil, and paper, pencil, the calculator, and then check in a little bit what the answer is going to be through this video. So, do this on your own. Otherwise, I'm going to go ahead and now show y'all what the answer is going to be. So, David is buying a new car for $29,850. However, he's only going to finance $27,850. So this is the number we want to pay attention to. He's going to take out a 5-year loan at 3% APR. We want to figure out what his monthly payment will be. So first step is to figure out how many thousands are going to be borrowed. So we're going to take $27,850 and then divide that by 1,000. If you remember your division rules with powers of 10, all we're going to do is move the decimal point to the left 3 times for 3 zeros, and we get 27.85 for answer 1, for our first answer. Or you could just simply plug it into the calculator. You're going to get the same thing. 27,850 divided by 1,000, and we get 27.85. Step 2, calculate the monthly car payment. We're going to take the number of thousands borrowed, which is 27.85, and then multiply with the payment per 1,000, which is going to be found using this table to the right. So this is a 5-year loan at 3% APR. So if we follow the table, our monthly payment is going to be 17.969 per 1,000 borrowed. So we're going to multiply this times 27.85. So again, 17.969 times 27.85. And we get, rounded to 2 decimal places, $500.44. So it should be $500.44. 44. That's the monthly payment for this new car that David is trying to buy. And that's the final answer. Making predictions. Equations can be used to make predictions by evaluating the equation. So we're going to be looking at a future value formula. If you remember 3.04, when we were talking about housing, houses appreciate in value as the years go by, especially if you make modifications to the house, if you improve on the structure, on the flooring, the house in general. Maybe you add a new countertop to the kitchen. Maybe you added a new sink. You repaired the floors, added new carpet, whatever. And as time continues, in general, houses will appreciate in value. It's the opposite with cars, because cars involve technology. And so therefore, as the years go by with technology, newer technology comes out. Those parts that built your current vehicle are getting more outdated as the years go by. And so they're not as valuable anymore. And so the value of a car will depreciate in value. With the housing future value problems, you saw this as a 1 plus R. But because we're dealing with cars depreciate in value, and therefore our future value formula has a minus in it. So P equals V parentheses 1 minus R, close parentheses, raised to the Y value. P is the predicted future value of the car. V is the original value of the car. R is the rate of depreciation in decimal form. So again, this is in decimal form. And Y is the number of years in the future that you're carrying this out. So let's look at example 2. Tosha is buying a new car valued at $18,120. It is expected to depreciate at an average of 15% each year during its first 5 years. What will be the approximate value of a car be in 5 years? So that, knowing the approximation of value in the future, means we're going to be using the future value formula. Except we know that this is depreciating in value, and therefore you need to make sure that your formula has a minus in it. So, first state the formula. We have P equals V parentheses 1 minus R, close parentheses, raised to the Y. I already mentioned what these values represent, so just look to the right over here if you want a reminder. Pause the video and just read it. We need to set up the equation. We need to figure out what we have from the word problem. So we have that the initial value, the new car, was valued at $18,120. So this is the P value. We know the R, the rate, is 15%. And we know the amount of years is 5 years. Okay, this is the Y value. What we don't know is the approximate value in the future. That's what we're trying to figure out. So we have everything except the P value. We're going to set up the equation as follows. 18,120 parentheses 1 minus 0.15. Notice how the 15% changed to its decimal form. Close parentheses, raised to the 5th power. If you forgot what the percentage is as a decimal, remember any percent you can always divide by 100 to change into its decimal form. So 15% as a decimal is 0.15. Okay, notice how we want to find the P value, and the P value is by itself. So we only have to worry about plugging the right side into the calculator, and then we will get our answer. So 18,120 parentheses 1 minus 0.15 close parentheses raised in the exponent to the 5th power. rounded to 2 decimal places, and this should be $8,039.94. If we round it to the nearest whole number, it'll be $8,040. That's it for example 2. You try number 2. Don is buying a new car valued at $35,750. It is expected to depreciate an average of 12% each year during the first 8 years. What will the approximate value of his car be in 8 years? Step 1, set up the equation using the values found on the left. So here is where you're going to input the values that you found on the left if you're following along in ClassKick. And then if there is no value available, put NA for that answer on the left. However, on the equation, if it was NA, then make sure you just put the letter that it represents. Step 2, type the equation into the calculator and find your answer, round to the nearest dollar. If you're on ClassKick, you can move this box to check your work to see if you're doing everything correctly. Otherwise, just make sure you're working through this on your paper, pencil, and calculator, and then wait for me to go over this problem in this video. Okay, so go ahead and pause this video, try this problem on your own. Otherwise, I'm going to go ahead and show y'all now how to do this problem. So, new car is valued at $35,750. That is the V value, our initial value. It's expected to depreciate an average of 12% each year. Depreciate means we need to use the minus version of the future value formula, which I've shown y'all here in ClassKick. 12% is the R value. Let me put that right there. So that's the R value, except R needs to be in decimal form. So 12% as a decimal is 0.12. If you forgot how to do that, you can just take 12 and move the decimal point to the left twice, or divide by 100, and either way, you will get 0.12. Then we have the amount of years that we're carrying this out for, which is 8. So that is the Y value. So we have 35,750. We have 0.12. And then we have 8. We do not, however, have the P value. That's the one that's currently being figured out, given the information that we have. So step 1, set up the equation. We have P equals 35,750, parentheses 1 minus 0.12, close parentheses, raised to the 8th power. All we have to do is plug this into the calculator. Notice how P is isolated by itself, and the entire right side is a number that we could just plug into the calculator and solve. So we have 35,750, parentheses 1 minus 0.12, close parentheses, raised to the 8th power. Hit enter, and then we have 12,857 if we round this to the nearest whole number. So 12,857. 12,857. The car will depreciate from $35,750 to $12,857 after 8 years at 12% each year. That's the final answer for you. Try number 2. Let's look at a couple gas mileage problems. So gas mileage is measured in miles per gallon, which is the number of miles driven divided by the number of gallons used. Again, MPG means miles per gallon. So to calculate the amount of miles per gallon, here's an example. Sue drove 330 miles on 13.2 gallons of gas. What is her gas mileage? Whenever you ask for gas mileage for MPG, that's usually an average of the amount of miles driven per gallon of gas used. So Sue drove 330 miles, which we will divide by the amount of gallons used, 13.2 gallons of gas. So 330 divided by 13.2 will be 25. So on average, she drove 25 miles per gallon of gas used. And that's it for example number 3. You try number 3. Dan drove 680 miles on 22 gallons of gas. What was his gas mileage? So again, go through the steps, figure out the answer on your own. If you're on ClassKick, you can move this box and check your answer as you're going through this to see if you're doing everything correctly. So if you would like, go ahead and pause the video, try this problem on your own. Otherwise, I'm going to now show y'all how to do this. So Dan drove 680 miles on 22 gallons of gas. It's miles divided by gallons to figure out the miles per gallon. So 680 divided by 22. We're going to round it to one decimal place. Let's call this 30.9. 30.9. So on average, Dan drove 30.9 miles per gallon for this trip. And that's it for you try number 3. Okay, another type of gas and mileage problem is trying to figure out the cost of the entire trip. So, step 1, we're going to calculate the number of gallons used. And we do this by switching around the formulas. So, I'm going to give you all an example, and one of the steps is to find the number of gallons used. So, we're going to switch around the original formula, which is miles per gallon equals number of miles divided by gallons. We're going to switch it around by cross multiplying, and then getting the following formula. Number of gallons used is equal to the number of miles driven divided by the MPG, the miles per gallon. Step 2, we're going to have a cost per gallon that we're going to multiply with the number of gallons used for the trip. And then we will get the entire cost from there. You can combine both of these steps into one big step. Number of miles driven divided by the MPG multiplied by the cost per gallon. So let's look at example number 4. Dina is planning on, let me cover some of this real quick. Dina is planning a 580 mile trip. Her car gets an average of 32 miles per gallon, and the cost of gas, so the cost is $3.40 per gallon. What is the approximate driving cost of the entire trip? Well, to get the amount of gallons that we need, we first need to divide the miles driven by the MPG. So we're going to take 580 and divide it by the average MPG, which is 32. And then this will give us the amount of gallons that we use to drive the trip, which is 18.125. Then we're going to use this number, multiply by the cost per gallon, and we'll get our total cost for the trip. So 18.125 times the cost, which is 3.40, is going to equal $61.63. So again, this is $61.63 for the entire trip that Dina is planning. 580 mile trip. That's it for example number 4. So you tried number 4. Jack is planning an 1,100 mile trip, and his car gets an average of 32 miles per gallon. The cost of gas is about $2.15 per gallon. What is the approximate driving cost of the trip? So step 1, first calculate the number of gallons used using this formula. And then step 2, calculate the cost of the trip by multiplying the number of gallons used and the cost per gallon. If you're on ClassKick, Again, you can move this box and check your answers as you're going through the work. So go ahead and pause this video, try this problem on your own. Otherwise, I'm going to now show y'all how to do this problem. So to calculate the number of gallons used, we're going to use the number of miles that we're going to drive for the trip, which is 1,100. And we're going to use the fact that his car gets an average of 32 miles per gallon. So 1,100 divided by 32. And we get, and we get 34.375. So this is the number of gallons used for this 1,100 mile trip. Now to get the cost of the trip, we're going to multiply the number of gallons, 34.375, with the cost per gallon, which we know to be $2.15 for this scenario. So now multiply this number by 2.15, and the cost rounded to 2 decimal places will be $73.91. So 73.91 is the cost of this 1,100 mile trip. And that's it for you try number 4. All right, now let's go through a problem involving auto insurance. We're going to look at calculating the total annual premium. There are different parts of car insurance that you'll need to sign up for by law. Especially Texas law, it is required for you to have insurance when you're driving your car. So, again, we're going to go through calculating the different types of insurances. There are different types of premiums that you can buy for each one. So if you're looking at this chart right here, there's liability insurance, which pays for the other driver's damages and medical bills if you are at fault in an accident. It is, again, required by law, in Texas at least, to have this type of insurance. There are different types of premiums and different types of payouts for each of these. And I think these are in the thousands. So it's like 25, 50,000 coverage, 50 to 100,000 coverage, 100 to 3,000 coverage, which covers the person and the accident. So the first amount is the coverage for the person. The second amount is for the accident. Then you have another premium for the property damage. Again, these are in the thousands. So these are premiums that you pay for the entire year. $25,000 for property damage at $175 premium, and so on and so forth. Then you have collision and comprehensive premiums, which is a type of insurance that covers your vehicle. Collision insurance covers damages from accidents, while comprehensive insurance covers damages from non-collision events. So collision is things that happens to your car that is mostly human error. Okay, driving into a wall, driving into another car, driving into a post, a tree, whatever. That is collision. Whereas comprehensive is things that are non-collision. So things like that involve weather, or some other things that aren't human-made that gets put into comprehensive. And again, these are different deductibles. So deductibles are what you have to pay before the insurance covers the rest. So there's a $100 deductible, meaning you have to pay $100 before the insurance covers the rest. And then you have different types of deductibles. You have $250, you have $500 deductibles, which they all have different types of premiums that you have to pay. Okay, so our first step when calculating auto insurance for these examples is to find out what our total premium is going to be from these different insurances. Then we're going to calculate, we're going to further calculate the total by finding out what your rating factor is. Now, what a rating factor is, it's based on your age and whether you are male or female. Now, these rating factors are basically done off of a risk thing, like a risk analysis. So the younger you are, the riskier the riskier it is to sell you insurance, because more than likely young people, and especially males, are going to get into more accidents than females. So you can see that the rating factor for males at 17 to 20 is higher than that of females. And they continue to be higher than females all throughout, because statistically males get into more accidents than females. And then even further than that, young males get into more accidents than young females. So that rating factor also gets applied to your premium to calculate for purchasing. Okay, so we're going to keep all this in mind and then look at this next example right here. I'm going to cover some of this up and then reveal it as we go. Excuse me. Example 5. A 20-year-old male buys 25, 50, 100 liability insurance, collision insurance with a $100 deductible, and comprehensive insurance with a $250 deductible. What is his total annual premium? What is his total annual premium? So we're going to calculate the base premium. These first two are going to talk about, let me move this right here, are going to talk about the liability insurance, okay? The bodily injury part of the liability insurance. So 2550 is looking at this amount right here, which is a $220 premium, which we're adding right here. The next part, the 100, is the property damage. So 100 property damage for 100,000 liability insurance coverage is a $375 premium, which we're going to add right here. Then we're going to go to the collision and comprehensive premiums. The collision insurance is a $100 deductible for collision. So $100 deductible means we're going to pay a premium of $215. And then the comprehensive is a $250 deductible. So $250 is $102. Add that all together, and we get $912 as our annual premium when we add this all together. The next thing we have to keep in mind is the rating factor. Rating factor is based on age and whether you're a male or female, and it's all based on statistics. Males at the 17 to 20 age have a rating factor of 3, which means we're going to multiply $912 by 3. Oh, whoops. Where'd it go? So 912 times 3. And we have $2,736 for our total annual premium. That's how much insurance is going to cost for this 20-year-old male that buys these certain types of coverages. And that's it for your final answer. Now, of course, if you want to find out what the monthly payment will be, this is just an aside. This is not a part of the problem. If you want to figure out what the monthly payment will be, depending on how many months this is being carried out, could be for 6 months, it could be for the entire year. Let's say you're paying this for the entire year. That's $27.36 divided by 12. You're paying $228 per month. Now, it could be that you're paying this for 6 months, which some insurances do have. They have a 6-month policy that you would follow. So maybe you divide this by 6 instead. And you're paying $456 per month for insurance. Anyways, that's an aside to this problem. Okay, you try number 5. A 23-year-old female driver buys 100, 350 liability insurance, collision insurance with a $100 deductible, and comprehensive insurance with a $500 deductible. What is her annual premium? Calculate the base premium, which is, again, is adding up all these different things from these first two charts. And then you'll get your base premium. Step 2, calculate the total premium by taking your base premium and then multiplying it by the rating factor, which is based on age and whether you are male or female. So go ahead and go through this problem. I believe the answers are on the next page. If you just move this, you'll see the answers to it all. Go ahead and pause the video. Try this problem on your own. See if you can figure this out. Otherwise, I'm going to now show y'all how to do this problem. So we know that 100 and 300 is the bodily injury. So we know that 450 is being added to the premium. Property damage is the 50 right here. So 50 means 245 for property damage. Collision premium is a $100 deductible. So $100 for collision is $215. And then comprehensive insurance is $500 deductible. So $500 for comprehensive, that's $85 right here. Now add that all together. 450 plus 245 plus 215 plus 85. Our total annual premium or base premium is $995. Now the next part, to calculate the total annual premium, we're going to multiply it by the rating factor. So 995 times whatever we get for the rating factor, which is based on age and whether they're male or female. So we know this is a female in the word problem, and then that word this is a 23-year-old female. So our rating factor is 1.2. So 995 times 1.2, which is $1,194. And that's our total annual premium. $1,194. That is the final answer for you try number 5. And that's it for 3.05 notes, and that's it for Unit 3 in general. If y'all have any questions, let me know. Y'all have my number and email through the course itself, so just look that up there if you need anything. Otherwise, you have all the other videos, and you can just rewind, fast forward as much as you want to try and learn these problems. Okay. Otherwise, let me know if y'all need anything. I will see y'all in the next video. Take it easy, everybody.